What's up, YouTube? Today in this stream my goal will be to load models, Minecraft models into my Raylib C++ Minecraft clone and to load models just like these. This is the fence gate and we'll be using this library that parses JSON files. And the reason we're going to do that because this is the Minecraft model. This text file, this JSON text file, this explains to the engine how exactly every model should be rendered. And this is important we do it from the start, because in my Java Minecraft clone, it became a big mess when I implemented it way later. And here is the same fence gate. This JSON file is for this fence gate. And here you could easily see how it's split up into these separate little cubes that are transformed a bit. This is how every Minecraft model is created, with a series of cubes. A series of cubes like this. This is it. This is the Minecraft fence gate. And all of these cubes and their transformations are described in this JSON file. This is each one of the cubes. Here it says from where to where it should be. And here it describes what textures it should use and how it should apply them. Somewhere there's culling, which means the face should be conditionally rendered, depending on the neighbor there. And some cubes need to be rotated, some textures needs to be rotated, but that's extra detail we don't need to worry about. And this is the current Minecraft Raylib clone. Yesterday we managed to make it so the terrain generates in real time, and this is it. This terrain generation happens on a separate thread, and this makes it so the main thread doesn't freeze and where we have to wait for everything to load. And this Minecraft block, this grass block, we've created it with a system that is exactly what we will need. I call it the cube mesh template. If we go to the sub chunk here, look at how, isn't this like, doesn't this remind you of something? I already have in Minecraft a class that can render little cubes just like in the JSON file. Look at how you have here from and to, and here the texture coordinates. And here in Minecraft, I render the block the same way. It's from 0, 0, 0 to 16, 16, 16. And then I give information about the textures. This is enough. Even here, we can render, we have enough to render the, for example, any model. For example, the fence gate. We can do it, but the problem is we have to manually look at this, then this to convert it to this, and then go to the next one, this to convert it again in this format and to combine them. We'll have to do this manually and look at how much information just this block has, let alone if we go to the tripwire hook. The tripwire hook has even more, and the repeater, the redstone repeater, they have so many blocks in information, and having this automated will be a lifesaver. That will be the goal for this stream. And I plan to do this by importing this library that reads and parses JSON files. And so we'll copy over, for example, the fence, since that's what we've already picked. Where is it? The fence gate. We'll copy over the fence gate JSON file. We'll read it. First, we need to import this library for working with JSON files. And then we'll have to create some kind of a class that will using the information from the JSON file to convert it to this code, to something like this. And then here, when we want to render a fence gate, for example, we'll say load model from JSON file, and that would be it, instead of having to manually describe the block. And if we have time, if we don't have any blockages, any problems, we may even be able to implement textures so that I don't have to rely on the copyrighted textures. That would be also very cool. And yeah, let's start it. We need to download this JSON. Yeah, we need to download this. Does it have any dependencies? Any submodules? I don't think so. Let's get it. Yeah. I put all my libraries in this vendor folder. In this vendor folder. Yes. So here, git clone like this. We'll wait for it to... This just downloads all the files of the JSON parsing library. And we need to run it with our project. If we manage to do that, the next step will be to move into the resources folder one of the Minecraft JSON files, one of the Minecraft models, and to see if we are able to read it and parse it. And here is it, JSON. Here is it, and it has a CMake list, so we can easily add it. Add subdirectory, vendor, and JSON. And here to add the project, JSON, what's the name of the project? This, most likely. It's most likely that. Add library. Yeah, most likely. So we need to link with it. See if everything is alright. It's compiling. And next, are there any includes we need to do? Yeah, it has an include. So here, JSON include, and that's it. And now we should be able to use it. Where are we going to test it? In the main, let's say. In the main. And here can we return so that it doesn't generate the whole terrain. Now here, let's actually include it. We can look at the example. Where's the example? Here there was a simple example. This maybe. Let's try it out. So what do we need? They use stream and JSON, and then here using JSON, okay, and now std is stream, and we need the file. Which file? Let's go in resources, new file, models, not file, a folder, we need folder. New folder, models, and here we need to copy over the, for example, the oak fence gate. Why not? Or maybe let's start with just the block. One simple block. Do we have something like that? Yeah, here. Let me think about it. Yeah, this will create our own simple JSON file just for testing. Grass block JSON, and let's open it. And here we'll have, so it has usually let's actually find the grass block JSON file. So I need to find it in backup, new, so I need to look for models, grass block, and it's using, here the issue is they have parents, and we'll not implement something like this. This would be a bit complex. Parent is block, grass block. This, and here, what's this? Grass block. Top, side, it has an overlay. What? Overlay. Yeah, we'll just copy this. We'll just copy this. So here, this is one simple grass block. Like this. And we need the textures, these textures. No particles, just bottom, top, side, no overlay, like that. Yeah, this tint index, let's remove this. Yeah, this is one simple this is one simple model, just a simple block, and let's try to read it. Let's try to read it. So resources path, and it's inside of models, and what's the name? Grass block JSON. And what next? And then JSON data parse this. And so let's put a breakpoint here. Build failed. Must have a return value. Okay, what did it read? It has here data. It's not reading it correctly. Has some kind of data. Let's step over. And what does it have? Yes, it has it. It has an object with elements, textures, and so the elements has this data should have yeah, it has. It's a bit difficult to go over it. So let's go back to the example. And how are we going to use it? Let's look at here. We have this. And then how do we use the JSON object? So you want yeah, parsing. Okay, it should be like this. And we need, this is our Minecraft model. So we want to access textures, bottom. Let's see if we can do that. Let's see if we can do that. So here, let's do trace log, log info. And here we need to give a text format. And or what if we just do data textures? Can this work? How do they do it? What do they do? Yeah, they do this. What is this? Create an empty structure. What if we just output it? Data. Let's do text or just a cout. Let's do a cout. Yeah, let's just do a cout. Yeah, it's getting it. Elements. It's getting elements. It's getting textures. Sure. And what if we do textures like that? We need to close the terminal. And here we have bottom, side, and top. Yeah, perfect. We are reading the JSON file and we are parsing it. This is exactly what we wanted. Now the next step will be to actually go through the data and create the actual model. So let's remove this. Let's remove this. And we have this cube mesh pool here. And let's create static void read from JSON file. String path. maybe like this. And to include all the, give all the includes, let's have this here, and then I want next. We'll have this path here. We'll comment this out, and in the sub chunk yo, what's up? Maps Games, what's up? In the sub chunk here, where we usually, when we manually create the grass block, here, instead of creating it manually, we'll call the cube mesh pool, read from JSON file, and here to give it the path, and this should be gone. This should be gone, and it should automatically prepare the grass block, but we need to implement it. Would you recommend learning Java or C++ first? I would recommend Java for sure, since you have to think about less things and you can easily transition. Like, I made my Minecraft clone in Java for many hours. I learned a lot. I tried when I didn't have experience, I tried with C++. It was too difficult for me. So what I did was I tried both. I tried C++ and I tried Java. And I preferred Java, so I stayed with Java because I could manage to do a lot more progress with Java. And a year passed, and now I feel confident that I can move to C++, and now I'm doing C++. Because C++ will offer me a lot more that I can do. Oh, and also, how do I do any game dev in Java? I couldn't find any tutorials. Well, I used OpenGL, but that's an overkill. Java OpenGL. This Java LWGGL. This a lightweight Java game library. This is what Minecraft used. This is what Notch used. This uses OpenGL. Yeah, it uses OpenGL, but it may be a bit difficult, and I use this learn OpenGL. This was my tutorial that I went through, learn OpenGL, and here you have everything you need. Here you have about lighting. You have cool examples. This is what I used to learn, and here is the getting started, and you get started by creating a triangle. But this is without using an engine, so it's going to be very difficult, because you spend so many hours and finally you have just a triangle on screen. And going from a triangle to a whole game is like, it's crazy work. From what I know, there's libgdx, and yeah, I haven't used libgdx. I would recommend to try many options just to experiment, like 30 hours with OpenGL, 30 hours with libgdx, 30 hours with C++, and see how you feel. Which one do you personally prefer? With OpenGL, I think the hardest part is getting started. Well, yeah, for me, the moment I managed to do my clone, It was my first 2 months. The moment I managed to... Where is it? This? Yeah, here I showed how I go through OpenGL. If it decides to load, and here I do all the examples. Here I do the breakout game. This was the first 2 months. And the Cherno has very helpful tutorials on OpenGL. This playlist is good. And here I made a 3D block. And the moment I made this Minecraft grass block, that's when I got excited and pushed myself. And in 2 months I had this terrain generated. And from here on it was history. Because this excited me a lot, and now we're here. Yeah, let's move on, because I need to make progress today. We're trying to read the Minecraft model from the JSON file, and we have parsed it. And I've already done something like this in the Java clone. We can copy most of it. The pool. Here I have read from JSON file. And in Java, yeah, this is, I go over all the cubes. And I have to see how are we going to do that with C++. Read from JSON file. Let's again go here. And return 0. And here, cube mesh pool. Cube mesh pool, we need to include it. Here we can just test it before the game loads. Cube mesh pool. We don't need template. We can even do this earlier before we even do anything. Yeah. And here, read from JSON file. Model grass block JSON. That's it. And here, can we do this? Include IO stream. We should get the textures. Parsing issue. What is your problem? Oh, maybe it cannot find the file. Let's copy it exactly like I've written it here. Paste it here. Yeah, models, yeah, it cannot find the file. Yeah, here it is. These are the textures, the bottom, the side, and the top. And if we do elements, it should read the cube data. And this is it. Faces. North, up, side. Where is from and to? And here is from and to. And what if I do... So what if I do it like this? Will it give me the first element? I think so. And what if I do from? What will it give me? Yeah, from is this, but is this just a text? How can I use this data? Because we need this data. Nice. I think I'll try doing some OpenGL stuff. Good luck with that. I started learning Java a few days ago and I don't understand what's the difference between const and final. Yeah, I haven't used const. I think I've just used final when I am not going to make changes to it, but I haven't spent time learning Java. I've spent time learning OpenGL since I had a plan in the future to move to C++, so I haven't spent time learning Java outside of the basics. How can we... let's see how do they actually use this. What's this? Since the parse function accepts arbitrary ranges, your own data source. What's this? When a boolean is parsed, a value is passed. String binary. Because in Java, I use the library to parse JSON files, and the library creates like you have to create your own class, and you fill it up here. This is the texture, this is the elements. It's a list of another class called element. In each element, you set it up how it should look like. And when it reads the JSON file, it creates the whole like class. It creates all the classes you would need, and I just work with the classes. But here in C++, I just have this JSON data object. And I'm not sure how to move on. Data object. What's object? What's this? Yeah, here it converts, like if you have a vector, it converts it to JSON, but I want the opposite. I want from this to go to this. Hi, can we see your game? Which one? Because this is the C++ one. Well, right now it's not. It will not run. Now it should run. This is the C++ one. And you should start loading the terrain, but oh, I've stopped it off. Yeah, right now we're trying to do something and I've commented out code. This is the C++ one, where we have terrain generation that loads on a separate thread. And we have the Java one. This is the Java one, which I've spent, this is my main project that I've spent the most amount of time in. And it's a lot slower than the C++ one since... Yeah, this is the Java one with a menu. If you notice you have the background, it's 360 degree. And when you hit new game, everything runs on the main thread, so the whole game freezes until the terrain generates. It's not like in the C++, and here you have the movement. But this is the Java clone. I'm trying to convert it to C++. You have your Steve here. You have zombies, you have skeletons, you have the bow, you can shoot around. Sometimes the arrows get like stick to the terrain. I have on the top left the debug screen, which just shows which direction I'm looking at. Main menu is an old screenshot. I haven't updated the main menu. And if we find a cave, we can toggle the, yeah, here look at the cave. Here it's easiest to see ambient occlusion, and if I press R, it will remove it, but it needs a little bit of wait time. And here, this is without ambient occlusion. Look at the massive difference, man. It's a massive difference. Without ambient occlusion. And now I'll turn it back on. And this is with ambient occlusion. We just add these shadows at the edges. Yeah, but let's focus now. Let's focus and do progress on the C++ Minecraft clone. Main. Here. And let's see how to get an array. Like I have this, where is it? This is the JSON file. I'm trying to convert this to C++. So what I need is a variable called elements that has an array of objects, maybe a structure. Yeah, I need to parse it, and I'm using the library to parse it. Where's the library? Here it is. It's parsing it perfectly. So their data, if I do like textures, like this, textures, this is it, this field, it parses it. So if I start it, it's finding the text, bottom, side, top, it's finding the text, and that's perfect. It's finding this text, and now I want to use it. So maybe I need to create a structure like called JSON texture, and maybe here to have bottom, side, top. Yeah, in Java, how do I have it? JSON textures. Yeah, it's a map from string to string. Yeah, so here I could have a map from string to string. Sure, why not? Textures. Sure, and then here to somehow parse it and to be able to use it. But I haven't used even once this library, and that's my biggest blockade. No ambient occlusion in main menu. Browsing VS VS Code IntelliJ outlines. What about surviving creative and block breaking time for survival? Yeah, we have those. Yeah, but that's in the Java clone. Like I don't want to touch the Java clone. I want to move to C++. Since here in the Java clone it runs at 80 FPS. 80. That's 80 on my supercomputer. Here you have the breaking. You have item drops. Like I have everything that I need here. I have it here, sure. But it's running on 80 FPS on a supercomputer, and it's running on how much RAM? On almost 5 gigabytes of RAM. Whereas the C++ clone runs on 800 FPS and on 200 megabytes of RAM. Massive difference. That's why I'm excited to use C++, and here I'm using Raylib. Because in the Java clone I'm directly using OpenGL, where I have to implement a lot of stuff from scratch, from zero. But here with Raylib I can reuse a lot of stuff, and I'm already doing it. Like here in the subchunk, the subchunk has a model, it has a mesh, and this is from Raylib. It has a mesh, the mesh has vertices, texture coordinates. I don't have to bother with that. That's a life changer. Like, that's super awesome. And that's why I'm excited to move to C++ and Raylib. It's like a big game change for me. So let's move on and not stop getting distracted. So what's this? Yeah, here every example is converting something into JSON. I want the opposite. From JSON to some kind of a structure. That's what I want. From JSON. Yeah, maybe this is what we need. This is to JSON. I don't care that. Yeah, person. And here, so I give it a reference. So I create an object, a custom one. Here they create a person, which has a name, address, and an age, probably. And here, at name, get to name, get to address, get to age. Okay, this is what we'll use. Perfect. This is what we want. So, let's think about it. So we have this whole object. We can call it block model, just like in the Java. Yeah, block model. And it has elements and textures. Let's just have textures for now. Yeah, textures. And can't we have some kind of a map? Are there any kinds of maps? STD map. Sure. And here, this is textures. So if we do data, here we need to create, let's create a block model like this. And how do they do it? They do at text. Let me think about it. Let me think about it. They do here. They call like the name, the key. They call the key. For example, textures. And here get to this. Okay, sure, why not? So here textures get to and block model textures. And is it a reference? No, it's perfect. And can we see out? Is there something we can print to the console? Block model textures, and can we get where's the JSON file? Can we get the bottom texture? The bottom texture. Can we get that? Yes! It worked! We can get the bottom. Yes, this is exactly what we wanted. Okay, from here it should be piece of cake. Yeah, we're reading it. And the next one should be a list of elements or a vector. Is there something like a list? List, include list. Okay. STD list of with element elements. That's it. And we need to create that structure element. And what will element have? Okay, element has from and to. From and to elements. Each element has a from and to, which is an array of floats. Let's do floats. So float from, and it's 3. And then 2. And what else? Rotation. Yeah, it needs faces. So it's a map from string to string faces. Oh no, it's from string to face. And now we need another structure. Face. And what's a face? And face is this. These are the faces. And this is one face. So it has an UV, which is 4-element vector. And here it has a texture and a cull face optionally. So it has float, UV, 4 elements. It has string. It has a texture. It has optionally a rotation, but std string cull face. It has a cull face. Faces. So can we do... So we're getting the textures. This is enough. And can we directly get... Where is it? Elements. Can we directly... Will it figure it out itself? Elements. Will it figure it out? No. We need to do it manually. We need to do it manually some way. So we need to probably manually iterate through each element and create this. Probably, I assume. I'm not sure about it. Most likely. Get to value type. What can be value type? Interesting. Where is this? Here. Or maybe we need to implement these functions default constructible. There's a way to bypass this requirement. Default constructible, what's this? Can be default constructed. Default initialized. If all following statements and expressions are valid, there are specified effects. Oh, so I need to implement this, and then it will handle it. What about IntelliJ? IntelliJ is where the Java Minecraft clone is, but I'm not working on it right now. Yeah, let's make the types default constructible, and then we'll be able to parse the JSON here. Yeah, maybe it's complaining that elements. So this element, this. So if I do, where is it? Let's try to do all of these and see if there's an error and to fix that error. So if I do element, is this okay? This is okay. Element And this is okay. Element. This is okay. Element. And this is okay. So what's the issue? Maybe I need to make a constructor. Because this is a list of elements. This. Let's simplify and see if... let's get the first element. And here to get... and here to target from. And here, let's make an element. Test. And this element to get from. Will this work? And here to... test from. Can I see out an array? No. X from 0. Let's do 2 actually. 2 because 2 is different numbers. 2 and let's do printf actually because it has formatting. X, Y and Z. And how was it? F, maybe like this. And here test 0, test 2, 0. And the other values to see if we got them. And we tested out. 16, 16, 16, it reads it. Okay. So if we manually go through all the elements, create an element and push it here, it can work easily. Easily. Yeah, I need 2 minutes. I'll be right back. I'm back. Now let's finish this, and so we can be, we'll be able to load any Minecraft model we want if we manage to finish this. And we're pretty close to doing that. Welcome back. Yeah, thanks. So, let's do this thing. Let's do this. Now, we have the block model and we have the textures. That's done. Where is it? This. The textures is done. Now we need to go through the elements, which is an array. And we don't know the size of it. Will that be an issue? Can we do for... JSON element from data elements. I assume we can do this. And then here to create element, here JSON element, and then we need to parse. This we don't need. We need from, no, at, from, elements, from. That's it. That's it. And we need the same for two. And now we have this, and we need the faces. So can we do data at faces get to element faces? Can we do that? Yes, perfect. And now block model elements append, no, push back element. And now can we do printf y z, then block model elements, the first element, at, no, how do we get from a list front? What does front give? Yeah, it gives an element, and there two, the first element like this, and see if it has worked. We can just debug it as well. This print will not be needed if we think about it. Let's start it. Error. From JSON to so here faces, it's a string to face. Yeah, most like, okay, if we remove this part, it's still having a problem. What's the stack trace? Here from. What's oh, we're doing data. My bad. We need JSON element. Yeah, it works perfect. And now what if we do it here, the faces part? The faces part doesn't work. We would most likely need to do something similar like here. Faces, and what's faces? It's... oh... yeah, it's a list. Let me think about it. Because here it was an array, and we iterated the array. But here it's some kind of an object with strings as keys. How did we do it in Java? Where is the face? Here the face. No? Element. Yeah, it's a map from string to face. And here how each face looks like. Where is it? Here. We can try to do the same here. And here it should be JSON face. And this to be JSON element faces, right? Faces, sure. And here to create a face, and for each one of them to get these things. Let me think about it. Sure, we'll be able to get these, but I still need this string. I need this string. I don't know how are we going to get it. What if I do auto here? Will I get the first and second, so the key and the value? Let's breakpoint it. Now, what's JSON face? Yeah, it's the same thing. Yeah, it has skull face, texture, UV. This is what we need, of course. Yes, but what's the key? I need the key as well. I need this thing down, because we'll create the face, sure, but we need to save it for the down. And this information to save it for up. We're missing this. How to get these ones? How are we supposed to get them? This is a JSON object. Maybe the way we iterate the list, we need to iterate it in another way. Let's look at the page, iterate, iterators. Iterate. What's this? My iterator. What's this? Here an iterator. Begin. And JSON iterator. Huh. Yeah, I think this is maybe what we need. Yeah, let's do this. Let's do this. Iterator. And it should be JSON element faces. Begin. End. And let's see what we get here. When we debug it. What is the iterator? Does it have the key? That's what I need. Down. It has down. It has down. First, it has first and it has second. This is what we need. Yes. Yes, 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 yes. This is what we need. So, what next? So, std string key and the face. And so the key should be iterator first. First. Come on. First. Iterator. What do we have? how to use it. Iterate the array. Yes, key and value. Yes. Perfect. Key. Key and value. Yes. So here face, we need iterator value. JSON parsed face. This is the face. So here we want what do we want? Parsed face at UV get to face UV, and then texture and curl face. Texture and curl face. Curl face, and then we want element faces insert, or can we do key equals face? Yes, perfect. And what's next? That should be it, actually. The main question is, does it still compile? Yes. And let's debug it to see the object we've created. Block model. It has one element. It has the textures, bottom, side and top, and it has the elements. One element, which has a from and to, and has the 6 faces. Down, east, north, south, up, west. And they have the UVs, they have the texture and cover. Okay, we're done. Yes. Yes. Oh man. Yes, finally. We did it. We managed to read and parse the JSON file. Read and parse Minecraft JSON file model. Then we push it. Git, no, here. Git status. What's the problem? Yeah, I need to add a sub module. God damn it. Status. Because I'm copying over the whole JSON library, which is a no-no. Can I undo the commit? Want to undo it. Git status. Git restore staged vendor JSON. Vendor git status. Let's remove it. The JSON folder. This is the library. And let's do git submodule. Git submodule at and then the library. What is it? come on. I need this. Vendor JSON. And this will clone it. And when I commit, it will not copy over the whole JSON files. Yeah, that would be cool. Once we are finished with the commit, we'll move on to using the data that we parsed with the JSON library to actually create here, for example, is the grass block, but we'll also have all the other files. We may to do a few slight changes since some files have rotations. Git status. Okay, and does everything run? Yes, everything runs. Here git add commit m add JSON library, git push. That's it. Now, where is it? Yeah, everything is perfect. Now we have the JSON model file as this block model structure. Now we need to iterate through it, just like I do in Java. Yeah. I'll move the Java code to the side, and this should be fast since I'm just doing the same code like I did in Java. Now, let me think about it. Let's go over all the elements. For element block model elements, we go over all the elements, and then now we go over all the elements. This music makes me feel I'm from 2006. Well, yeah, it's quite a bit old soundtrack. It's the original soundtrack. Now we go over all the elements. And what next? I need to create cube mesh pool get template. And for the template, we need to set the from to equal element from, like this. Can we do directly this? Will it handle it? No, it will not handle it since it's an array. From, and then we need to set the to. And then we will ignore rotations. We are ignoring rotations. We need to go over. So we are going over all the elements. We have from and to. Now we need to go over the faces for each element. As maybe an iterator. So for auto iterator equals element faces begin. Iterator is not element. Faces end. Iterator. We increase it. And let me just check list iterator CPP. Do I need to do a const reference? No, it's just an out. I could do it as std list iterator list. It's an std string to face iterator element. Oh, it's a map. The map. Now, these are all the faces. So we go over all of them. Let me think about it. We need the curl face. And it's the... So face equals iterate value or second. This is face object and face string. This is the first. And so the curl face, yeah, let's do curl. The curling is 0 by default. The curl mask is 0. Then we need if there is a curl face. And what is it? It's a string. We do a switch. Face curl face. Can we do a switch? Enum type. No. Damn it. We do an if else. We do an if else. If face curl face equals, do we have equals? Equals down. Else if face equals this. 1, 2, 3, 4, 5, 6. If it's up, if it's north, if it's south, if it's west, east. So curl mask will be curl bottom. And here it's curl up, curl north, it's curl top, oh my god, curl south, curl west, east, and then we go over And then we want, what do we need? Let's go back to the file. We have the cull face. We will give this as an integer, so it knows if it should cull or not. And I'm actually wondering if we go here as debug. Let's look at the faces. Block model, elements, faces, and here cull face is down. And what if there isn't one? Because sometimes there isn't one. What happens then? Oh, come on. I have to do a case for that. Can I do a check? Contains cull face. So here, if it contains, else face cull face is empty string. Block model, elements, faces. Yeah, cull face is empty string. Perfect. Perfect. Yeah. So if it's not empty string, we'll have a cull mask. Perfect. And here we want we want origin X of the texture and origin Y of the texture. Origin X and Y. And then bikini index. And then I should get what's textures? Get textures. Substring. Yeah, what do I do in Java? Texture ID. The texture substring. Okay. Yeah, I get it. So this thing, I need this. I need this, and to ignore this number sign. So this is std string texture ID equals block model textures, and now I need to get from the face texture, but I need to ignore the first element. String remove first character. Erase the first character. Just need to erase the first character. Erase 0, 1. String before. Okay, erase 0, 1. face, texture, erase, 0, 1. So from the start, erase one character. That's it. And so now this is a texture ID. Here it would be best if it's a map, actually, instead of a if else. Here, std map, std string to integer, call sites to equal down to be call bottom. 2, 3, 4, 5, 6. Up, north, south, north, south, east, west, curl top, curl north, south, east, west, and here it will be curl mask just equals curl sides, face, curl face. That's it. I don't need to do an if. That's it. And I need to do another map. Std string to what should it be? I have in Java, I go over all the possible texture IDs, which they should set my origin X and origin Y. I could have two maps, one for X and one for Y, and repeat these ones, or to have a map with string and pair. Let's see what are my options. What are my options? Texture to ID to origin. And here, can I do like an array? I need just a pair of two integers. There is a vector too, actually, but it's using floats, I think. Needs to be integer, but whatever. And so here, let's do, I need block dirt. I need block dirt, and here I need block dirt is this is the bottom. This is the bottom, so it's this 32.0. 32.0. Then I need grass block top, and that's 0. That's on the 0. And then I need grass block side, which is which is 480. 480. And here I'll just do vector 2, texture origin, texture origin equals texture ID to origin, texture ID. That's it. Very simple. Very, very, very simple. And then face rotation, we don't have something like that. And now I need to set up the culling, which is we have from and to. And yeah, and to set, now it's this part, to set UVs and origin. And this is should be the last part. Let me think about it. And it all depends on which phase we are. We can do it based on the curl mask. No, it's not based on the curl mask. It's different. It should be, we can do can we do a switch on an integer? Yes, okay, so here can we do once more curl sides, face string, curl bottom, bottom, this will be faster. Three, 4, 5, 6. Top, north, south, east, west. And so we need to get the template. If it's the bottom curl bottom mask needs to be the curl mask. The origin bottom UV origin needs to be, what is it? It's a vector 2 actually. Texture origin, and we need to set the UV, bottom UV, to be equal face UV 0, like this, 0, 1, 2, and 3. And rotations, we don't have any. Let's copy this. Here, this is bottom, this should be top. This should be top. This should be top. This should be north. This should be south. And this should be east. This should be east. And this should be west. And that should be it. And we need one other thing in the template. Here the defaults should be -1. And in the mesh pool now we need subchunk. We need to set the next template, but where? This goes through all the here actually. Here. Yeah, here, next template. And so we are ready to test this and see all the possible mistakes. Let's see if it compiles. It compiles. And let's remove this and go to subchunk here. Remove this. And now we should be reading the grass block from the JSON file. Hopefully. Fingers crossed. Fingers crossed. Nothing is happening. Let's see the console. Model. No, it's not loading even models. Curl faces. Yeah, let's see what happens when we hit generate. Positions. No, what happened? Let me think about it. Current. How are we supposed to debug it? Okay, let's do a conditional debug here. Conditions if curl pay. Come on, why isn't there an autocomplete? When curl faces is not 63. If we are not culling. Cool thing, cool that you doing C++, I guess. Is that, I guess, IG? And what's happening? Let's remove the thread function. Let's remove the threading. And let's simplify it to just one subchunk. Let's simplify it and see what we get. Let's continue here. Let's try again. It's not generating, so let's bring back the condition. If curl faces is not 63. Let's see what do we have here. Curl faces is 62. So let's go inside. Current template is 1. Perfect. Perfect. Mesh template. It has from, it has to. Perfect. North UV is alright. Bottom UV is perfect. Origin. Perfect. Yes, and bottom is this. The size looks okay. What's positions? Positions is just zeros. That's very weird. It shouldn't be like that. Oh, we haven't generated it probably. Yeah, we need to generate it. Generate. Like this. Curl face is 62. So curl top is -1. Bottom -1. North -1. Wait a minute. Oh. Yeah, it sets up this. Oh my god. No, this is not what I. No. It's culling everything by default. We don't want that. Let's see how I did it in Java. Here I generate. I clear all of these. And when do I set clear? When do I call this? At the end, I call the clear. At the end. At the end. So not here, but here. And there should be one more thing. Current face. That should be here. Current face 0. And there was one more thing. Which one is it? The culling. By default, when there is no cull, should be -1 maybe, not 0. If there is culling, sure, we'll set it. But if there is not, it will be 0. That's very weird. But let's test it out. And let's keep this. Yeah, it's rendering. And there is culling. Sure. And let's go inside. And this was loaded from a JSON file. The block data. 20, 20, 10. And let's bring back the multi-threading and see if it works. It's not loading JSON file from a thread. That's weird. That's really weird. I'll be right back. I need 2 minutes. back, and while I was gone, I got an idea. Since most likely the issue is that it cannot read files from a separate thread, probably that's the issue. We could maybe read through all the files beforehand and to cache them, to cache the information somewhere and to just reuse it. And we can do it. Let's remove the threading. And see if everything works. Oh, it's struggling. It's struggling. I get it. That may not even be the issue. Okay. It's struggling. Let's make the world smaller. And let's see if it will manage with multi-threading. Okay. No, everything is working fine. The issue is that for every block, it reads, it's reading from the disk, the JSON file. We need to cache that. It was just very slow. That was the issue. It was just very slow. So we can... let's commit this. Reading, loading, Minecraft JSON block model from disk. Every request. We are reading from the JSON file for every block, which is extremely slow. We want to cache that information, and then we'll be golden, and we'll be able to load any model we want. And how are we going to do that? Cube mesh pool. We can make a function that prepares all the files. Let's move back these files into here, and let's have in the data, we don't need this mutex, let's leave it. In the data we could have, what you call it, a map of string to block models, that's it. And this will be the file path, and we'll make a function static void init, maybe, that goes through all the files. String models folder equals resource path models. This is the folder, and so in this folder I want to go over every file. And to prepare its block model and store it inside of this map, so that we can reuse it and not have to parse through it for every time. And how are we going to do that? And hopefully this will not be too much memory taken. It's 48 bytes. 48 bytes, so 48 times, if we have 100 block model JSON files, it will be this bytes to megabytes. It's nothing. It's nothing. We can cache it. We can cache it. And so we just need the names of all the files in this folder. That's what we need. Get file names in folder C++. Raylib cheat sheet file. Raylib had access to files as well. File system management. Upload file data, save file data, export data as code. Load file text, unload file. File rename, copy move exists, directory exists. Get file name, get directory path. Change directories path file. Load directory files. We can directly use Raylib probably. Get directory file count. Perfect. Yeah, we can even just use Raylib. So load directory files. Yeah, just this. File path list. File path list. Models equals this. Models. And let's in main here return here and do cube mesh pool init and test. I just want to stop here. What if can we actually stop here? Build failed. Include map, cube mesh pool, map list, like this. Models. Okay, we can remove this. So models has one file and the path is this. Perfect. 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 And I need to parse through it. I need to parse through it. For models paths. We can do auto. Oh, but it's an array of arrays. It's a 2D array probably. It's an array of yeah, it's an array of strings, but the strings are of pointers to characters. So we can iterate through it. Equals 0, I less than models count, I plus plus. And so printf models paths I. Yeah, it's this dev to the engine sandbox, resources, models, grass block JSON. And for each of those, we can directly give it to the if stream, sure. But I'll need a key to access it, the name itself. Get file name. Yeah, we can get the file name. Yeah, we can make a function. We can make a function void load block model, and it can take const character pointer path. And inside of here, we'll do data block models. So the key will equal, it will equal get file name path. That will be the key. And we want here read from file. We want all of this. All of this. All of this actually. Here, path. We have the block model, and now we do data block models. And what's your problem? Oh, we have this JSON data. And so data block models key equal block model. That's it. Or maybe even can we create it first? Here equals this to create it and reuse it. Directly. Yeah, this should load block model, and so here load block model models paths I. We load all the block models, and here we can do model name block model to equal data block models model name, like this. And to change this model name, And in subchunk, this should be just the name. And in main, let's test it. Works. Let's breakpoint it. Let's breakpoint it and look at the models. No, look at block models. It has size 1 grass block JSON. It has textures. It has elements. Should be fine. So we init it. Let's init it here. And hopefully now it's faster. It's very slow. It's very slow. Maybe we'll need to use the profiler. Okay, let me think about it. It's no longer cube mesh pool. Where is it? Here. It's no longer reading from files. No longer doing that. Let's commit it. Cache all block models. We're saving the information, and so if every time we need the grass block, we already have it. We already have it. And here we get the curl sides. Can we have this in the data? Or like somewhere else, not here? Maybe in cube mesh pool here as static. Const static. And we need to initialize it. Maybe inside of the JSON file. Inside of the CPP file. Like this. And remove this, that's it. And here, now what's the issue? What if we build it? No. Oh, because it's const now. Because it's const. Let's remove it. Let's remove const. Yeah, now. Is it faster? Yo! I think it's a bit faster, but not something to brag about. And how can we make it even more faster? Because I'm ignoring some parts. Like this should be world height 10. This should make it a lot slower. And now it's super slow. It's super slow. And memory process is, yeah, somewhere we're doing a big mistake. Let's go. Yeah, what's actually happening with the mesh uploaded, and here process memory? Why is it increasing so much? Let's profile it. Read from JSON file, profile function, and let's restart this. Let's start this. Let's see what's up. It's a lot slower. It should have been done here in 6 seconds, but it's super slow now. Do we have something of the memory? No memory data collected. Damn it. Go through all blocks. What's this? Go through current block neighbors. Read from JSON file. Prepare mesh template. Yeah, the preparation of the mesh template, it's a lot slower. $57. This thing. 57, and let's do it like before. And of course I've commented out history. Subchunk. This. This is what it was before. What's the issue? I'm trying to do it like before, to not read from JSON file, but we still have, oh, the culling. The culling. The culling. Void default culling. Set default culling. And these here, curl north, curl south, curl west, curl east, curl top, curl bottom. And here mesh template. Oh, maybe even we're just not are we getting it? Yeah, we're getting it. Set default culling. This should work. Yeah, this is what we want. This is a lot faster. This is what we want. And what's the main difference? What's the main difference? So we are looking at we are doing work that we don't need to be doing. That is for sure. If we manage to find where this is happening, we'll be golden. And we'll be able to load any JSON file we want. We have a very, very small issue at our hand. Should be easy to find. But I'm thinking about it. On what should be our approach. I'm thinking about it. Damn it. So we go over every block. If it's air, we continue. And here we go through the neighbors. This is not an issue. And we check if we should draw face. And so if cull faces, if we are culling all faces, continue. Will this do improvement even now? We need to close this. Whoa! So much faster. And we need to do one more thing. Here, now let's test this part. Now let's test this part. It's good. It's good. We can compare them. How much the difference is. And let's restart the profiler. Let's see the difference. Yo, so fast. Now let's look at the profiler. It generated the meshes in 3.7 seconds. Man, this... Even we made it... We first improved it from 18 to 6 seconds in the previous stream. And in this stream from 6 to 3 seconds. We halved it 2 times. The speed for generating the blocks. But this is without using the data from the JSON files. Generate blocks. Generate blocks. Yeah. Imagine if you paralyze it. Well, my goal is not like I'm not trying to improve the speed. I'm trying to load Minecraft JSON files. that's my goal. This was just an accident. So here is generating the blocks in okay, the total time. Let's look at the total time. The total time was 3.7. And now with JSON files. Oh, let's reconnect it, I think. Discard, reconnect. Now let's reconnect it. This is from the JSON file, the data. These grass blocks are from the JSON file. And I think this is it. Let's look at Tracy. The profiler. How much slower it is? 6 seconds. Double. Man. It's double the time. It's very slow. Let's see what where. Damn it. Are we going to be able to see where the slowdown is? Here. Read from JSON file. So we've cached the file. Maybe I need to get it as reference. Even const. Yeah, to get it as reference. And here, as reference. And here a const iterator. Not the think about it. Const face. Oh, come on, how to iterate? Let's do an out here. Out. Yeah, that fixes it. And here, textures. Block model, textures. It's const. We don't have access to it. I just want to read it. Find at. Yeah, this is it. Anything else? And here let's do a const for the face. And here I need string texture equals this, and then texture erase like this, and then now is it better? I think it's a lot faster. And let's check it out. Let's check it out in the profiler. Discard, reconnect, start. To see, ignore this. Tracy, did you read something? Discard, reconnect. Now let's start again. Let's see how much faster it is. Before it was 6 seconds, around 6. The goal is around 3. Let's look at Tracy. How much it is? Maybe put your guesses. I'm thinking it's 4 seconds. Thinking 4 seconds. 4.8. And yeah, to handle JSON files, we've slowed down with a second. A second. So if I load up the mesh template for each cube manually, it's a second faster. This is a second faster. Let me think about it. Here, this, I do this, and the difference is here. I need to first get the block model, which should be fast. This is just a map. I want to see if it's possible to bring it to be the same speed as manually setting it up here. If not, we'll move on and see what models we can load, like the foliage, for example. But even for the foliage, we'll need rotations. So we said we go over all the elements. We set the from, the to, and we iterate over the faces. Read from JSON file. Do we have it here, this? Find. Yeah, we have it here. Read from JSON file. We are calling it. Total time 1 second. Let me think about it. Let's screenshot this. Or maybe let's add here, we have a profiler, so we can profile zones. But I'll be right back. 2 minutes. I'm back, and I've thought about it while I was gone. I think we don't need to bother to optimize it even more, because we have what we need. It's good enough. If I need more optimization, I can look at it off stream, but we can move on and see if we can draw foliage, for example. So yeah, it's like 5 seconds now. It's like, it's not, yeah, it's perfect. I don't need to further optimize it. It's good enough. And so we can move on. And I'll leave this commented out here. Let's commit it. Generating terrain using JSON models at 5 seconds. Yeah, let's just move on. We are loading the grass block from the JSON file. That's perfect. And now to test it, let's do foliage. Let's look at my terrain generation and copy the generation of foliage. Subchunk foliage. Grass here. It's here. And what now? What now? What now? Yeah, I go over all the blocks on the X, Y, and Z. Sure. And I calculate a Perlin noise and a surface level. Sure. Why not? And then I set the bedrock. We don't need to bother with bedrock. If we set the dirt blocks and stone blocks, we don't need to bother with dirt and stone. If it's at the surface level, we set we have 1 in 600 chance to spawn a tree. Else if it's from 1 to 100, we queue grass. This is it. Why do I need queue? Because it's the block above. Yeah. Or maybe we can do trees. Let's do trees. Maybe. Let's do trees. And let me think about it. Or grass. We can do grass. We can do some experiments. Let's go back to the mesh pool. I'll need to copy these values. Here I'll need to copy and let me think about it. Which blocks will we add? Which blocks are we going to add? Let's do the stone block as an experiment. Let's do the stone block. So here, new file, stone JSON, and here stone. It uses cube all. We just uses cube. This is it. And it's a bummer we don't have parenting. Faces. Why don't they have UVs like this? So it should be Let's call it all. We need a way to reuse these blocks. We need a way to reuse them. And here all will be... It will be... Stone JSON. They use stone. This is the stone block. We need to copy this. We need to copy this, and here let's create the stone will be this. It's 16.0. 16.0, and in the sub chunk let's change it to stone. Let's see if every block now is stone. Yeah, every block now is stone. And so let's try to let's make trees. And to do that, we'll need random value, random, get random value, get random value, and it's inside of here. We need to set these things. And for now, our types are ones and zeros. They have a default UV. If not specified, they have a default fallback. Yeah, I'm right now simplifying everything so that we can move on, and if in the future it's a problem, I'll think of some kind of a system to improve it, but as of now we move on. So let me think about it. Here, when we are at the surface level, so this is when we are below it. This is if we're global Y above it. This is where if we're above the surface level, it's air. Else, this is when you're on the surface. No, let's do it like this. This is if we're above it, and here, if we are on the global Y equals surface level, if we are on the surface level, here I want a random value from 0 to 600, both included. Sure. Oh, yeah, 0 to 600. And if random value equals 0, this is 1 in 600 chance. We can do from 1 to 600. There is a small chance, and so we want to queue. We want to put in a queue a change of block type. And how are we going to do that? A singleton class maybe. Block spawner pragma once block spawner, and here we'll want public void q block, and needs a vector 3 position and type, and void spawn blocks. That's it. And let's create block spawner cpp include block spawner, and here let's create the definitions and create a structure block spawner data, and do a static block spawner data, and inside of it we'll have what? Include a queue, we'll have a queue of vector 3 positions and integers actually. Struct block spawner node vector 3 position and int data block spawner node blocks queue, and here we'll blocks data queue at push position type, and here we iterate the queue. Let me think about it. Yeah, for block spawner node from the data queue, and we do, damn it, it needs to be a global block origin position. So I need position details, sadly, position details. And this will use the node position and position details set block. We need to, let me think about it. We need a new function, void set block type, and here to do this, and if we are able to find a sub chunk, do not return, but set the type like this, and in the block spawner set block type to node data, and then data blocks queue clear or delete. How can we clear it? We need to do while data blocks queue empty. while it is not empty, node data blocks queue pop. Need to do this, and remove this. And so inside of subchunk here, 1 in 600 chance to, let me think about it. I need to include it. Block spawner queue block. The type will be 2. Type will be 2. I don't know what type 2 is. Let's say stone. And the position will be no, it will be subchunk origin plus x, y, and z vector 3 float. What's your issue? Must be relative to specific. It should be static. Like that. And the y should be +1. Then after all of these, but this for the subchunk. No, inside of the main, here we need to include block spawner, and in the terrain generation, after we've generated all the subchunks, to call block spawner spawn blocks, and inside the renderer, when we generate the mesh here, if block type, current block type equals 1, else if it's 1, it should be grass block, else it's stone. What are you crying about? Oh, we need the CMake list to restart it, to build everything. And what's your issue? Cube mesh pool in game was not let's run it again. Let's delete out and prepare everything. Okay, let's run it. What's the issue? The same issue. Hot reload. Oh, this thing, come on. No? Huh. What is the issue? Oh, here include Raylib block spawner block spawner node block spawner data blocks queue What's the issue? What's the issue? Okay, let's see. CPPQ example. Yes, a Q. Pop removes it. Q pop. Q front. Oh. Front. And yeah, let's do this. Block spawner, block Q. This. And the front. And what's your issue? Node is undefined. No, it's not. This. Now it's defined. Yo, we have the stones. Yeah, we have these stone blocks, which will be the positions of our trees. These stone blocks. Perfect. These will be our trees. Nice. And now let's actually add the tree models. Copy. Paste. Let's have I think it's oak. No. Lock. It's lock. Oak, lock. Oak, lock. Yes, oak lock. Oak, lock. And here it's and here it's what is it? Oak lock. It has end. It has end. And it has side. Oak lock top. And oak lock for the side. And the end should be for down and up. Oh, I've removed the down culling. Shit. Down, my bad. And now I have to change this everywhere. That's why we need parents. Man, I didn't have culling for down. Oh no. Oak lock. This is the end. And this is for the side. This is for the side. And now I need to input these. This. Need to prepare them. Oak lock. And what are the coordinates? Oak lock top is this. 96.0. 96.0. And this should be minus 16, which is 80. 80. And let's do main. Where is it? Subchunk. Here. Let's do oak lock. Now it should be oak locks. Yeah, now we have oak locks. And the faces are being cut. Yeah, we need to continue the trees. And how do I do the block spawner here? Block spawner. When I queue it, I put in the block ID, position and direction. What of the position? Set block at global position. And what does this do? It gets the check origin, local block position. Interesting. Let me think about it. Let's continue the trees. I'll do them like I do them in Java. Where is the subchunk? Subchunk. Or I could give it position details for the queue. For the queue, not sure about that. Can I do it position detail? And here like that, and here subchunk, and here start position to be position details to be let's calculate local block position. This to be this, like that, and here to give it local block subchunk origin, give it that, and yes, and here to give it start position, go up const vector 3. This needs to get position details. Yo, I'm back. What's up, the real splits? You were in the previous stream, I think, like yesterday, and you said that I said your name, pronounce it right. I remember that. Yeah, of course I remember. It's not like I have 100 viewers. When I have 1 or 2 viewers, I remember everything. What's the issue here? And should be perfect. Subchunk Q. No. What's the issue? Block spawn. Int type. Like this. What's the complaining? Q block. Q block. Yeah, that's it. It's all right. What's the issue? God damn it. Yeah, there are no errors. Yeah, maybe. Okay, let's see now. The sun. I want the sun. When I opened YouTube, I immediately clicked on your stream when I saw it. Nice. The sun. This is not the stream for the sun. We'll have to get to there and make a separate stream for the sun, clouds, and moon. Maybe use an enum for your types instead of raw values. I'm using the raw values temporarily. It's temporary. It's very temporary. Run. What's your problem, man? Missing. Oh, include. Why didn't you tell me, man? Position details. You just had to tell me it was missing. Yeah, now we have these blocks, the trees. And now let's continue the trees. We need more locks up and the leaves. And we need the leaves. Let me think about it. Subchunk here. Yes. And let me think about it. I need how many locks? Trunk. I need 6 locks. I need 6 locks. So for loop, I less than 6, I plus plus. And start position equals start position go up. And here, no, here to do position details, lock position, and here lock position, and then lock position equals go up like that. And now this should have 6 locks. Yeah, 6 locks. Are they 6? 1. It's hard to tell. 2, 3, 4, 5, 6. Maybe 1, 2, 3, 4, 5, 6. Yeah, I don't know. Maybe they're 6. And now the leaves. Now we need the leaves. The leaves. How are we going to do the leaves? We first need to create them. Copy, paste. leaves, leaves, oak leaves. Also here I'll do oak leaves as well. Oak leaves. This, and it will be for all sites, all, and then here will be texture all, and then in the here if it's type 2, it will be oak log, else if it's type 3, it will be oak leaves. Isn't a queue just a fancy vector? Well, it depends how they've implemented it. I don't know how they've implemented it. But in comparison to the vector, the queue has a very limited API to just push and pull, and I cannot access a particular member. Oak leaves, and let's put just as a test. Where is it? Again in the subchunk here as a test. Block type 3 and see what happens. But we need this texture. Cube mesh pool here. The oak leaves texture is this. It's on the 112.0. 112.0. And see how the leaves are rendered in Raylib. Oh, they use blending enabled, I think. They use blending enabled. God damn it. I just need to discard the pixel when alpha is less than 0.5. That's the only thing I need. I don't need blend enabled. Now I have to figure that out. And we need to fix up the culling. Here, this bottom face should be rendered of the leaf, and the top face of the lock should be rendered as well. How are we in terms of FPS? Around 800. We are still perfect in terms of FPS. Yeah, I have to figure out how to disable the blending and how to change the shader in Raylib. That's what I need to do. But should I do that, or should I continue at least to finish the block, the tree structure, so that I can commit it properly to be more organized? Here, let's finish the structure, the tree structure. We need do the leaves, but how? God damn it. In Java, I also use a block spawner and I queue blocks, sure. This is so that when one subchunk writes and the other one doesn't overwrite, because trees will be in a couple of subchunks at the same time. That's why I have a block spawner. And I've done the trunk, that was the easiest part. And now the leaves. What do they use? They go up 3 blocks, then -2, -2, and a 2d4 loop. A 2d4 loop that skips the center and sets the leaves. This is the one level, and then to go above and do the same thing. And then the third level is a smaller rectangle that skips the center, but also skips some other parts. Oh, maybe skips the diagonals. How am I going to handle the leaves? Let me think about it. Damn it. Damn it. Not sure. Here I directly set the positions. These are global positions of the block, and the block spawner will handle the details of what subchunk this is and what local block it is. But in my case, in C++, I handle it outside of the block spawner, and so this way of defining where the leaves are will be a bit different. I use this class position details where I just give it a position, I give it a chunk and local block position, and it will handle when going up and down, it will automatically change which subchunk we are in. It will automatically do that. Let me think about it. Yeah, I'm not sure what would be the best approach. I'm not sure. I'm thinking about it. I have the grass block on which we start the tree, and I have the end of the lock, the last lock position, and going up once starts where the leaves are, and one level above it should be the last leaf in terms of y direction. Let me see my leaves, how they look like in Java. I think it would be like technically best if I can somehow define it somewhere and it to automatically handle everything. God damn it. So this is the structure I want. And we are at that leaf at the top. Also, we can go north, south, east, and west and set them as leaves, then go down. And again, southeast and west. Damn it. This will be the easiest part at the top, but this part below, I'm not sure how to best set it up. Let me think about it. I can set the same way to be for these ones as well, and we'll need to fill up these ones. Or I can directly go here and in a for loop. Damn it. I can make a 2D for loop and start from here, and on the second for loop to go down, then the first for loop to restart from here and to go to the north, a few blocks until I have this level at the center. And then I go up and do the same for this. And then I do the locks. And then I do this pattern at the top. That's what I'll do. And that's how many blocks? So it's 2 blocks. 2 blocks. I'll do something like that. Let's bring this back up. This is the... I'll comment this out. We have the starting position. And how many blocks up? So we have the... This is the starting position. This is the starting position. And we go up once, 2 times, 3 times, 4 times. Yes. So start position. Go up 1, 2, 3, 4 times. You know what? I can change it. I can make, because go up creates a copy. I need 2 versions. Position details. I need 2 versions. This will be void. And this will be get up. Like that. Like that. And here I'll have a copy. And I'll tell the copy here, go up and return the result. And here, that would be best. And me think about it. No, actually. Position details. Even this can return a reference. But like I want to return this itself. I want to return itself. Class CPP return self. And does it need here to be like to have a reference? Yeah, what's about this? Returns the unchanged number. Man, I'm bad with C++. Yes. And so here we can do this creates a copy. Yes, this creates a copy. And here it's go down, go east, west, south, north, and here go up. Doesn't need this. This. It will return itself. Go down. Like this. Damn it. Like that. And so in the subchunk here we can now easily go up without making copies. We go up 1, 2, 3, 4. How many times? We go 1, 2, 3, 4 times. We need to go up 1, 2, 3, 4 times. And here we need to get up, and here this to be a position leaves start details. Here it creates a copy and that copy continues on. And then we need to go, we can go north, let's say. So north 2 times and west 2 times. Go north and then go west. Maybe this is probably super inefficient. And block spawner. Let's just create a leaf there. just to test it. Yeah, it creates a leaf. And now we need to continue it in 2 for loops. For int x equals 0, x. How much times? It needs to be 1, 2, 3, 4 times. 4 by 4. Less than 4, x plus plus. And here y. Now here this. So we've went northwest. Now the second for loop will go south. Let me think about it. Fuck. Let me think about it. And here start. Damn it. I need, like, here. I need this block, I have it, and I move here. And I want to go back here and to change it to the east and do the same again. Then go back, change it to the east. Here, go back, change it to the east. How? So start, and then here I want like the start, and then start, go south, like that. Sure. 4 times. And then at the end, start, go east, like that. But now here I'm reusing the same one. I want start copy. Start copy. And this, and start go east. Start is here. Start. And what will happen now? No, doesn't work. It didn't go back and go to the east. It should go... my directions are messed up. Doesn't matter. It should be... Okay, we have the start. Oh, this needs to copy the start. Yeah, like this. Like this. Perfect. And we do the same. We do it once more. And now, the start is here. But this should go up. Damn it. Okay. Yes, perfect. And now we do the locks. Now we do the locks. Subchunk. Now we do the locks by reusing this. like that. Lock position. Get up. Lock position. We queue the lock position. And then lock position go up. Like this. Yes, perfect. And now here we need north, south, east, west, and to go down, north, south, east, west. And here equals lock position. And now here like that. And now we do we do here get north, south, east, west. And then we do the same. Go down like that. And this is just for the trees. Yeah, we have the trees which have blending enabled, which we want to turn off. Oh, what? 1 second. What's the issue? 1, 2, 3, 4. 1, 2, 3, 4. And here 1, 2, 3, 4. It needs to be more. It needs to be how much? 1, 2, 3, 4, 5. By 1, 2, 3, 4, 5. So we're here, we go this. 1, 2, 3, 4. 1, 2, 3, 4, 5. Oh, so here 5 times. Let's try it again. What's the issue? Oh no. Not like this. It needs to be here 5. And what's happening? We're close, man, and we're close. Let's do 4. And let's see what's happening here. So I start here, I go up. 1, 2, 3. Yeah, here I go up. And I go 2 times in a direction, 2 times. Good. What is this? It's a tree. This is the tree. I go up. I go here probably. Here. Then I go north, west. I go. Damn it, the negative Z. Yeah, the directions are messed up for some reason. West, north. Damn it. The directions are messed up. So go 1, 2. Go 1, 2, 3. I need to go a 4th time. And it's not going a 4th time. And here it's not going a 4th time. Let's see now. Here, I'm creating the tree. Leave start, we go north 2 times, west 2 times. Then I paste it, then I go south. Oh, let me think about it. I go south and I need to go, then paste it again, then go south again. Yeah, that should be it, but it's not. And now yeah, I think I get it. Leave start, we go up, then we go north, then we go north again, then west, west again. Let's see why the debug position is bad. Because I need to know where are the directions here. I need the directions and they're not working. Am I updating it? Here, draw text. Get directions, sure. Yes, I'm getting them. And here, I use the camera target with the left, with the positive X and positive Z. And I normalize the camera target. Yeah, here they work perfect when I'm at the center. Oh, so I should probably subtract main camera target, camera target, vector 3 subtract camera target and camera position. Can you make commands? I can make commands, but they're not a priority. Or do you have an idea of why I will need right now commands? Do you mean command blocks or the console, to write in the console? What if we do it like this? North, west, southeast. West, south, east, north. Okay, this is the north. It should be. Negative Z, north and west. So I go from here, I go north. Then north again, then west again. Here. One, two, three, four. Damn it. Subchunk. Okay, man, we're trying to spawn a simple tree. Start position, leaves, leave start is going up few times, then to go north, and then north again. Then north again, sure, and then we go west, then west again, and then the start point is exactly there. Make a copy, and the copy is what I move to the south. I move it to the south. I do 4 times this. Oh, what if I... how should it be? So from here, north. From here, north and north again. And to the west, here. And I do 1, 2, 3. Yeah, but this is... it should be 5 times. 1, 2, 3, 4, 5. It needs to be 5. And then here, it needs to be 5 by 5. It needs to be 5 by 5. Let's start again. And now it needs to be moved. So this is the north and west. This shouldn't be here. Why is it like that? Lock position is the start position. I shouldn't have changed the start. Yeah, here. In here, I get up. Damn it. Let me think about it. Here I get a copy. Damn it. Why is it not at the right positioning? Why is it here? The leaves should be offset quite a bit more. Okay, let's test out. Here to go north again and go west again. And see what happens. It's still the same. It's still the same. Start position. When we queue a block, does it do a copy? No, it takes the reference. It takes a reference. Let's make copies here. Let's make copies. Let's make copies. It's still... Man, it's infuriating. It's still the same. You're kidding me? And these are just simple trees, man. Like, we have so many more complicated things to do, and we're stuck on some simple trees. Start position. Leave start. I here get up. I create a copy. Leave start. Yeah, let's we need to debug it. Obviously. Start position. Nice, T3. Can I look at it? Start position. Does the start position change? Here. Let's look carefully. Does it change? Lock position. Lock position is 8. This is 5, 7. Subchunk origin. Perfect. Block origin. Yeah, perfect. Block origin. Minus 155, minus 43. Now let's look at leave start. So the Y, we don't care about that. The block origin is not alright. Block origin is not alright. Block origin is not fine. Yeah, here is the issue. It's this part. So how are we going to debug this? Go north. Block origin. This is on the Z. It's minus 46. Now it's minus 47. Now it's minus 47. Now it's minus 48. In here. And here it's minus 47. Oh my... Michael... No. Wait a minute. Let's make it return a reference, man. I think this is the issue. I think it returns a copy. And I need to change it here. Here. Yeah, finally. Oh my god. Yeah, finally. And now we should make it so the culling is doesn't call the leaves and doesn't call here the lock. So I need to make a slight change. Subchunk should draw face here. Here should draw to make it like this. And here we should return let's do ball is current block transparent. This is if current block type equals 0 or 3. Like this is temporarily. Is neighbor block transparent. This is temporarily. And if either of them is transparent, now let's see it. And here we're drawing everything. But we need to disable blending. Let's commit it. Drawing trees. Push. Raylib disable blending. Let's look at the reference, blend. And blend mode. Drawing. I don't want. I haven't started a begin blend mode at all. If we look at the code, the main, I have begin drawing and begin mode 3D. Begin drawing. To start drawing, begin mode 3D. Custom camera. Raylib shader. Raylib shader alpha cutout. I want to disable blending. Was this example? Spotlight rendering. Oh, let's just search the code itself. Let's search for GL blend. Geo enable blend. And where is this enabled? Man, this is my favorite part, that I can look up the Raylib source code. This is my favorite part, and not only can I look at it, I can change it. Have complete access. I should have started this way earlier. The init. And doesn't this enable color blending? And how can I disable it? Don't tell me there is no way to disable it. Where is this code? Init window. No, this is Android. This is init window. In there, it goes here, and it enables this annoying blending. Enable blend. Let's see if there is somewhere disable blend. Disable. Oh, it's a function. Oh, but and where is it used? Find all references. Why is it enabled by default blending? It's never used. What? That's very weird. Can I search just Raylib source? GeoBlend. Yeah, it enables it once and that's it. God damn it. We can try to change the blend function at least. I don't know. Raylib geo disable geo blend. Oh no, can I directly call it? Like in the main, when I init the window here, blend, disable, blend. It was geo disable, geo blend. Inside the entire workspace. In RL, can I use those? RL, disable color blend. Can I directly use it? Yo, I can directly call it. I disabled the blending by calling that function. Man, this is amazing. Man, I love Raylib. Man, this is amazing. Man, Raylib is so cool, man. You can do whatever you want in Raylib. Whatever you want. Literally. And Raylib, Raylib shader. And how can I check out their shaders? Load model, load texture, set the texture, set position, and then array of shaders where they have all kinds of shaders. Current shader. And they go through all of them. Where is this used? Begin shader mode. Draw texture rectangle. What? Draw model. What does the model use? It's just a texture. Source code, yes, perfect. And where are those shaders? They are in resources, shaders, in resources, shaders. Resources, shaders. Let's look at this version. And how do they do it? Do I need, can I just do fragment, or there's a vertex as well? Base. Yeah, I can send a shader. Let's look at the cheat sheet. Shader. Shader. Begin shader and shader mode. Load shader. Set shader value. Can I look at the fragment shader? The base fragment. Final color. Do they have here? Here do they have discards? This is the mask. No. Let's, we have to make our own shader. Not an issue. Right? Not an issue. Add folder shaders. Terrain FS. Terrain VS. And we'll copy over terrain VS, terrain FS, like that. And let's try to use that, and maybe even the color, to always output a red color. Vec4 RGB alpha. like that, just so we are certain we're using our own shader. And now how can we do it? Hey, I closed something. And here, okay, let's load the shader. Let's load it. Here, shader equals load shader. Yeah, I can use, this is for the vertex shader, it will use the default one, because we only need to change the fragment shader. Resource path, shaders, right? Shaders, terrain, fs. Okay, we have the shader. What can we do with it? What will happen if we leave it like that? Okay, nothing, sure. Now we have the shader. And then, oh, it's afterwards when we here. Oh, it's drawing to a texture. Oh my god. Why is it doing it like that? It has a target texture. It has a... Where is it? It has a target texture. It draws to it everything. And then it draws the texture through the shader. Oh my god, why is it doing it like that? Why is it doing it like that? Like this, target. Let's do this. 1920, 1080. Like this. I need to clear it to unload it. And then what? Here it draws to the target. Here I need this clear color. I need this, and using the camera then to draw this like that, and then begin drawing. Then begin shader mode. And then this is the shader. This is the shader Was it complaining? A rectangle and a vector too. And a vector too. Let's test it. It should draw everything red. Ooh. Everything is red. And why is it struggling like that? Let's change this to be like this. Yeah. And now let's discard the alpha. If texel color alpha 0, oh, don't turn, oh my god, don't turn it, man. 0.5 discard. And what's going on? What's happening? Speak to me. Why are you white? Why is it white? What the? Why is it white? We get it from the texture, texel color, texture and coordinates. Let me think about it. What's wrong? Main. Maybe because here we clear it. It needs to happen before that. This is like an after effect for the whole screen. This is different. This is different. This is an after effect. Damn it. Hey. It's an after effect. It's an after effect. A post-processing effect. We'll do the same thing when we draw 3D. Yeah. Like that. Let's bring it back here. We'll comment this, and here to make it red. And let's test it. No. It should be begin shader mode here probably. And here. Like that. No, only the grid is using the shader. The model is not. Yeah. Let's remove this shader mode. Let's remove it. And let's see if we can change it for the model. Where is it? Where is it? draw, and generate model here. No, here, this. Can for the material subchunk model materials maps shader. No, come on. Raylib set model shader. Materials shader equals shader. Yeah, that's what we need. That's what we need. Shader equals shader, and we need access to it. Shader. Here, we need access to it. Shader, here. This. And here, shader. Shader. And main. Shader. That's it. That should be it. And everything should be red. Yes, perfect. And now let's... Man, Raylib is amazing. That's what I'm going to use for sure. Terrain FS. I love Raylib. It's my favorite. Now we should have the cutout. Yeah, we have trees. Finally. We disabled blending and we enabled trees. And now we should have foliage as well. Foliage should be easy. Foliage should be easy. Let's commit it. Let's commit it. Where? Where's the GitHub? Alpha cutout shader. Like that. Next, we want... What's next? Yeah, I want foliage. But to have foliage, I'll need rotations. I'll need rotations of the models. And before we move on to foliage, I'll be right back. I'll need again 2 minutes. Yo, what's up? I'm back. Now I want to have foliage. Do we have any commits? No. Let's create the JSON file. Let's just copy this, paste, grass, and now I'll copy which one should I copy? Door, oak, piston, redstone, sticky piston, tripwire. Grass, short grass, tinted cross, this. Oh, and here it says to not have ambient occlusion for it. That's interesting. Yeah, but sadly, to implement to load the grass model, we need rotation. Only that for the elements. I'll remove this tint index, or it can just ignore it. And particles. Textures, we need cross to be, what do you call it? Grass. It's short grass. The cross needs to be this. This is it. Shade, we ignore shade. We need to get the rotations on the X, Y, and Z. Here is just the Y. We need to implement rotations if we want foliage. We need that. You mesh template pool. And how should I have rotation? In Java I have it for sure. But this is for rotating everything, I think. Rotate Y. Let me see. For the elements, origin, get origin. Yeah, I'll need rotate X offset and rotate X angle. Yeah, in the template. I'll need that. Oh, damn it. Here I need load rotate Y, rotate X, Z, and vector 3. The offset like that, and then And then when we clear it, we set the rotations to 0. Sure. And before we clear, we need to implement these methods. We need to implement these methods. This should be const reference, I think. I'll change it later. Now it's good too. I need a method rotate y angle x and z. And here const like this, and now rotate y angle equals to radians. CPP to radians. Damn it. Isn't there a function I can use? You must be joking. Okay, then cosine and sine. Cosine. Yeah, I need a math library or Raylib. Damn it. This needs to rotate y angle. Sure. And then inside the CPP, where is the clear? X, Z. And then those Raymat, okay, Raymat. Cheat sheet. Do they have? Okay, I need to be back. I'll need to be right back in 2 minutes. I'm back. Do they have here cosine? Sine? No. CMath library. CMath. Sine, cosine, etc. Okay. Include CMath. And here, okay. We need to rotate on the Y. So the angle, we need to convert it radians to radians. Do they have radians? Cosine takes angle of radians. Okay, radian. And they have nothing about radians. Oh, damn it. Radians. Okay. CPP angle to radians. This. And where should I put this function? In the globals, maybe? Question mark. Void 2 radians float angle return. And what about pi? Does CMath have pi? They should at least have pi. Math H Math H versus CMath. CMath pi. M pi include CMath H. CMath pi. And what's the issue? This is a float. Float like that. And then here you mesh template to radians angle like that. And then we need, here I even need to remove this. And then I need what's the origin? Oh, the origin is this. Huh. I need to divide it. So it cannot be constant. Here, origin 16, and then cosine equals angle. And then the sine. And then for each of the positions, we remove the origin. Then float and then like this, then position plus equal origin, like that. Now the other rotations. We'll ignore the other rotations since the grass needs only the Y. And then I need in the block cube mesh pool even when I load the models. Cube mesh pool init load block model here. This cross, it needs each element. Where are the elements? An element has from to, and it has a rotation. Rotation, so another structure. A rotation has float origin 3 values. It has axis, it has angle, like that. And so here in the element, if JSON element contains rotation, then I want element rotation. Where is it? Then I want the rotation origin to be no. I want JSON element at rotation at at origin get to element rotation origin, like that. But if it doesn't have a rotation, if it doesn't have a rotation, what should it be? If it doesn't have a rotation, like to be a pointer or what? I'll think about it. Because if I do a pointer like to the heap, when I do new, I'll have to at some point do delete, or I could make it like a smart pointer. I need some kind of a null value, but or maybe an array of rotations. No. Damn it. Damn it. Let me think about it. Here, rotation. Yeah, let's fill it up and we'll think about it later. We want the axis. And we want the angle. Else, if there is no rotation, just to set it as zeros. Just zeros. And what else? And so inside of when we process it, so QMesh pool, does this run? First of all, there is a build fail. A lot of warnings. Damn it. CMAF. This pi value. There, I'll do it myself. Like this. And next. And here, angle. And here I need CMAF. Already defined pragma ones. I need pragma ones. Yeah, I have it. So what's the issue? Where should I keep this function, man? Already defined. Where should I keep this? I'm back on the stream, everybody. What's up? Hello. Where should I keep this 2 radians function? Can I have it? No. Yeah, let's just move it. And move it to cube mesh template. Oh, maybe we can do it like inline. Global inline. And what was I testing? Yeah, we're trying to add foliage. We're trying to add grass, particularly. To add grass and then flowers. We're trying to add grass. So, if we go when we generate the terrain, here, where is it? Here, this. Else if the random value is like between 1 and 100 to queue in start position, go up, block spawner will queue up block type 4, and let me go back to subchunks. If it's block type 4, it will be grass. It will be grass, and should draw face here. Grass is also transparent. And at some point I should move away from integers as types. And let's check it out. See what happens. This is the grass. And I need to give it a proper texture. And it's actually rotating. Let's see what texture is it using? Grass. This. So I should go inside of the pool. Here. And what is the texture? This. 3216. 3216. And see what's up. This is the grass. And the culling, it shouldn't be culling. Should draw face here. if it's type 4, oh, it's the current block. Neighbor. Now this should work. How's it going? I'm drawing the foliage, so the grass. Here, the grass. I'm drawing the grass, and I have the trees. But I need to fix up the rotation. I don't think they should be at 90 degrees. I need to change up the rotation. But I'm very happy with the result. I'm very happy with the result. But let's use the rotation because it's not rotating it. Where should that happen? Q mesh pull. Here I set the rotation and we need to use it. Here for each element. When we set from and to here, we need if element rotation angle is different than 0, then we need to set, we need to check the rotation axis. If element rotation axis equals x, else if y and z, and here I need to get the mesh template, rotate x to equal element rotation angle, and here is the y, here is the z, and we need the offset. We need to set up the offset equal to element rotation offset origin. 1 and 2, that's it. And here this needs to be for y, this needs to be for z. Let's see what happens. Is it rotating it? Yeah, now it should be like at 45 degrees. Okay, now we have grass. And let's add the flowers. Let's add the flowers. Add grass foliage. Now let's add the flowers, which are just a copy of the grass. And what were the names? They were like poppy and something else. Poppy and what was the other flower? Dandelion. So this is let's look them up. Poppy. This it's that, and then copy this. This should be dandelion. This is the cross. And then we need, and how do I spawn them? And then I have to go in the sub chunk. Here I need some noise. I call it foliage noise, but let's go to continentalness. Let's do here get foliage noise, and here to be, I don't know, just this. Here double foliage. Get foliage noise, and that will be on here. How do I get the noise? This here. And if foliage noise is 0.6 F, I could do +1 divided by 2. If it's more than this, and then again with the random value, and else if 100 and 250, and here 250, 300. To block spawn here 5, and here to block spawn in start position go up. Here to block spawn 6, and so in the sub chunk, if it's 5, 6, poppy, then the lion, and for the transparency, this became here. This is 5, 6. They are all transparent, like that. And what do we get? Oh, I need to set the textures. Yeah, I need to set the textures. Poppy, this. Where is the cube mesh pool? Like this, and Poppy, Minecraft, Poppy is the red one. Red one is 6416. Poppy 6416, and dandelion is 4816. Like this. And let's start it. Now we should have foliage. Yeah, now we have foliage. Yeah, it's very cool. What's the FPS? It's still 800 if I don't record. It's pretty alright. And what's the RAM? 1 gigabyte, but if I disable the profiler, it will be less. So let's disable the profiler. Tracy enable. Let's disable it. And how much is the RAM? It's still 1 gigabyte. What did we change for? Oh, the blocks. We are caching all the blocks. The JSON files that we have, we cache them, but they're not that many. Yeah, I'll have to see where all of that is going. But it's still less than 5 gigabytes that we have in Java. Let's make the flowers be less. Let's have them be less. Where? Inside of subchunk. Get foliage, I think. Get foliage here. And how is it now? Man. Nah. One zero. Here 1 0. Get continentalness. Subchunk. Here noise. Let's remove this. And here noise. Let's remove this. And here let's make it if it's higher than 8. Sure. Let's make it higher than 7. Then 7. Let's make it higher than 7.5. Yeah, and this should be it. We have this is the end. We can load models from JSON files, and we proved it by loading the flowers. I didn't call the flowers. I'm just loading them from the JSON file. The grass is from the JSON file. The trees are from the JSON file. All of these are loaded in from Minecraft. And we have now the world is looking a lot better. And so the next step would be ambient occlusion and lighting. Maybe, and we'll get pretty close to the Java clone. It's really cool. And Raylib is my favorite place now to code in. Raylib and C++. It's my favorite place right now. It's very cool. We have flowers, we have grass, we have the trees. The leaves are transparent. The leaves are transparent. Foliage. Down below there's nothing. Super cool. It's very cool. It's very cool. Yeah, we need lighting and we need ambient occlusion. That will be the next stream. Maybe support for textures. I don't know. Man, this is very cool. We have trees. We have foliage. What? This is so cool. I'm not that excited since it has been 5 hours and I'm just tired. But we did well today. Man, it's so cool. And I have to figure out why is the game using 1 GB of RAM? Where is that coming from? How much it is now? It's still 1 GB. Have to figure out why it's using so much RAM. Because I'll be increasing it pretty soon. Because each block needs to have light data. And that will increase the usage of RAM. And here I'm noticing the rotation is off. Since this shouldn't be like that. It needs to be positioned differently, but it's fine now. It's fine, it's not that bad. Oh, and maybe to add a player as well. But a priority will be ambient occlusion and lighting. That would be a priority. Ambient occlusion and lighting. Yeah, it's very cool. Man, it's so cool. I saved a screenshot for the thumbnail, and that will be it. Yeah, thank you for watching. I'll see you next time.